Hi, Jayesh. How are you today?
Hey, hello. Good afternoon. I'm doing good. How are you?
Thanks, good. Okay, are you ready to give us your talk?
Sure. Yes. Uh, cool. So, good afternoon, everyone. Today I will be talking about distributed tracing, which is getting a lot of mind share in last 2 years. Some people even call it a new foundation of DevOps, but we will see if it really justifies its fancy new title. So, I am Jayesh Ahire. Currently, I'm founding engineer at Traceable.ai. I'm also AWS machine learning hero and video champion. So, at Traceable AI, we are building a modern AppSec platform based on distributed tracing and machine learning. We also have open source our underlying observability platform called Hypertrace. And apart from my day job, I'm also involved in some AI research around distributed neural computers from last few years. And if you want to talk to me around my work or collaborate on some different projects, you can ping me on Twitter and I'm happy to talk about it. So, let's go through our agenda for next 20-25 minutes. We'll see why observability became important and what is it. And then we will discuss in particular about distributed tracing. And then we will see a demo of an application instrumental with tracing. So let's jump into our first broader point for today, observability. So monitoring or traditional APM solutions have been around from quite some time, and as this code says, that monitoring tells you whether your system is working, and observability lets you ask why it isn't working. And this why here is very important. So let's first jump and see why do we need observability in the first place. So there are multiple reasons behind requirement for observability. So let's just walk through our thought process, which will help us understand the situation better. And let's just conclude on why do we need observability. So most of the tech giants, including companies like Amazon, Netflix, started to build their systems using monolithic architectures back in the time because it was much faster to set up a monolith and get the business moving. And getting the business moving was the first important thing at that time. But over the time, as product matures, or as we say, fat growth happens, with growing systems, the code gets more and more complicated. They all faced the problem and looked at the microservices as a solution. So one of the biggest benefits of adopting to microservices is that microservices can be developed, deployed, or scaled separately, and you can even replace or upgrade any part of the system independently. So everyone started adopting to microservices, and here we are today looking at bunch of different complex modern architectures. So one of the benefit of working with older technologies was that limited set of defined failure modes. Yes, things broke and things break, but in the previous times, you would pretty much know what broke at any given time, or you could find out quickly because of the common failure modes. But as the system becomes more and more complex, the possible failure mode also became more abundant. And we created monitoring tools to help us figure out what is going on in the guts of our software. So we kept track of our application performance using monitoring data and time series analysis over a period of time. But this process was manageable for a while. It got quickly out of the hand. And when we look at the modern systems, with everything turning into open source, cloud native microservices, which are running on a Kubernetes cluster, they are extraordinarily complex. And even going further, they are now being developed faster than ever. If you have seen the keynote, Steve mentioned this, like between CI, CD, DevOps, agile development, and progressive delivery, the software delivery train is also speeding up day by day. And with this very complex distributed system being developed at the speed of a light, the possible failure modes are even multiplied. Like when something fails, it's no longer obvious that what caused it. We cannot keep up like with simply building applications or doing better monitoring. Nothing is perfect. Like everything breaks at some point, everything fails at some point. And the best thing we can just do as a developers is to make sure that when software fails, it's as easy as possible for us to fix it. And unfortunately, many modern developers don't know what their software failure modes are. Like in many cases, there are just too many of those. And even going further, sometimes we even have unknowns in our system. Means you won't put an effort into fixing something or some problem because you don't know that problem exists in the first place. So when we talk about standard monitoring, it is what the kind that happens after release. it cannot fix this problem because it can only track known unknowns. Like tracking KPIs or reporting performance, it is only as useful as that reporting accurately represents the internal state of your system or it determines the failure accurately. So we can say that your monitoring is only as useful as your system is monitorable. And this concept of monitorableness has a name, and we call it observability. So let's just put it into a definition and see what how we can define observability. So in a control theory, observability is defined as a measure of how well internal states of our system can be inferred from the knowledge of the system's external output. So simply putting, observability is how well you understand your complex system. And metrics, events, logs, and traces, or melt as we call it, are at the core of the observability. But observability is about whole lot more than just data. And like why we need it. Like consider your process of placing an order on Amazon failed due to some query timeout. So what characteristic did the queries that timed out at 500 milliseconds share in common? Maybe browser plugins or service versions, something like that. So here, instrumentation provides us the data, and queuing the data answers are some of the questions. So telemetry, a collection of a data from instrumentation, is a very important part when it comes to observability as it aids observability in a way. And but we have to keep some things in mind like telemetry data isn't observability itself, and instrumentation code is how we get the telemetry. So to aid observability use cases, your application needs to be instrumented in the first place. But basically telemetry provides us the same underlying view into the same truth. So let's just talk about metrics, logs, and traces, which will help us transition into tracing itself. So first thing, metrics. Metrics are basically aggregated summary statistics, and they are so valuable because everything from operating systems to application generates metrics, and at the least, they are going to include name, a timestamp, and a field to represent some values. Since so many resources come ready to tell us about themselves, metrics are first obvious place to start looking into your monitoring systems. Whereas the second thing, logs are like detailed debugging information emitted by processes, and logs are perhaps the second most important tool in the monitoring toolbox because virtually everything logs information and like about what they are doing at any given point. And other than that, logs tend to give us more in-depth information about resources than in general metrics because if metrics show that resource is dead, logs will help us see like why that resource died in the first place. And our focus for today, the third thing, distributed tracing. Uh, Distributed tracing it provides insights into a full life cycle of a request, which happens throughout the system. Like traces allow you to pinpoint a failure or performance issue, and currently with so many application interdependencies, these operations will typically involve number of hops throughout your system or multiple services, and those hops are what we call spans. So we'll see about this terminology in later slides. So traces add critical visibility into end-to-end health of an application. They are, however, like solely focused on application layer, and they provide limited visibility into health of the underlying infrastructure itself. So even if you collect traces, you will still need metrics to get the full story of your environment and logs to understand the problems. So APM tools feed trace information to a centralized metric store. So traces provide like a nice source of data for an app-centric view if you want it. So structured data can be translated into any of these forms like metrics, logs, and traces, and they all hold their own importance. But interconnecting them will help us make things easier as well. So let's just finally discuss about distributed tracing. Like that is why we were in the first place. So as I said, observability is all about understanding how transactions flow throughout the network and infrastructure. So if you consider a monolithic Java application, for example, like for just understanding, it's feasible to reason about the state and performance of the transaction. So if a client makes a web request, perhaps to a load balancer, to a web application or server, some database transaction happened in the backend, and maybe say some entry got created or record got updated, something like that, and the response is generated back to the client. So although there are hops in this entire process, this transaction is basically a linear path from client to server. Like client generates your request, which goes to load balancer, then A1, then A2, and maybe like at one point that just response goes back to client and the request got terminated. So it's hops, but it's still like a linear way. So it's quite possible to instrument each of the hops and visualize the state of the transaction and its performance to the monolith. But modern distributed system comprise several microservices. Like when we see something like this, it's a very complex entity. And even this doesn't satisfy our use case because this is not the actual system. The actual system will be distributed in a region way as well. Like in a real world use case, some services might be located in different regions and different locations. So you have to consider that thing as well. So when you look at this modern distributed systems, as we see, like these are very complicated. There are multiple transactions happening. Maybe like several services are talking to each other, several services are talking to databases. And when you see distributed trace for this kind of a system, it's complicated. So ASIO service A calls service B, then service B might be calling service C, and then service C is replying back to service A or service B. So there are multiple transactions happening over here. And this lack of clear linear path makes it very challenging and tedious to track the transaction. It's often very hard to map a client's request to a transaction since there is no single service which we can map to. So relying on the traditional and the conventional tools for performance monitoring and bottlenecks might not provide us a clear insight on what exactly is going on where. So how is distributed tracing helping us here? Tracing tracks actions or events inside your system or inside your application. It records timings and collects information about the nature of the action or event, and it maps that to a trace. Like to effectively use distributed tracing, we need to instrument our code basically and to generate a trace. So it can generate a trace and for a particular action we want to monitor. For an instance, we want to monitor HTTP request or gRPC request, then you have to you have to instrument that code itself. So the trace wraps the request and records the start and end time of the request and the response cycle. So putting it in very simple word, here, trace is literally a hop by hop map of your request. So, for example, booking a cab in the normal days, as you all know, comprises of calling several microservices like authentication, ride discovery, then pairing service, then calling APIs, payment service. So, these are several microservices you just call one after another to book a one cab. And these are just some I name. Like there can be thousands of services behind uh, one single request. So you can here you can see that a complete ride we can call it one trace, and all these intermediate service calls are hops, that is spans. And as we trace the journey of our ride throughout the system, we call it distributed request tracing. So why do I care? Why do I care about tracing, or why should you care about tracing? So tracing reduces time in triage by contextualizing errors and delays. It helps you visualize the latency, like what time your service took or for what time your service was waiting for other services. And it helps you understand your complex microservices like asynchronous code or maybe like your very complex microservice architecture. It lets you see your architecture with live dependency diagrams built from traces. So let's just focus a little bit on terminologies here, and then we'll jump to demo for sure. So span is a primary component of a trace. A span represents a individual unit of a work in a distributed system. So spans usually have a start time and an end time. First span in the request is called as the root span, and all the subsequent spans are called as the child spans. So here you can see that. So a trace constitutes more than one span. In our example, like as we have seen that complex microservice architecture, like BA2, B3, etc. were the request, and those were the spans in our trace. The spans are linked together via trace ID, which makes it possible to build a view of the complex life cycle of a request as it propagates throughout your system. So spans can also have user-defined annotations in the form of tags, and to allow us to add metadata to the span to provide assistance in understanding the where the trace is coming from, or adding context to it, uh, it provides that functionality. So you can definitely go ahead and add your key value pair data to it. Then like, if you want to know more about trace or read more about tracing, you can follow the open tracing documentation as well. It depicts the examples of typical span and illustrates it in very easy way. So now we have this trace data like coming from our system, and what will we do with it? So with this trace data and its span and span context, all the data, it will be then supplied to backend where it will be indexed and stored. It is then available for queuing or to be displayed on a visualization tool, which we will see in demo as well. So this is how, like, let's just see, like, this is how generally your trace looks like in a real world application. You can see, like, this is a trace for one single request to a particular API endpoint, and then like, these are several spans for different microservice calls. So cool. So I guess we can jump to demo. We can quickly see a demo and then move forward. But before moving to a demo itself, I will just spend a little bit time on what the application we will be using for a demo, Hypertrace. So Hypertrace is a real-time observability platform that helps teams make sense of their production requests and trends in the network. It's a distributed tracing platform. So Hypertrace converts distributed trace data into relevant insight for everyone. So infrastructure teams can identify which services are causing overload. Application teams can understand which requests put their service objectives at risk, and deployment teams can know if a new version is causing some problem. So Hypothesis accepts all major tracing data formats, which means that if you have already instrumented for Jaeger or Zipkin or Oten, you can try it without changing your application. You can directly you can use that default configuration, and still Hypothesis will be able to see and visualize your data. So we created Hypothesis at Traceable and open source it because we thought it will help a community a lot. And now we are seeing some traction over here, and community is helping us to make it one of the major better platform for observability and distributed tracing. Cool. So enough talk. Let's just jump to a demo quickly. So if you want to check out Hypertrace, or you want to try it out locally, you can just go over here, github.com/hypertrace/hypertrace, and you can clone this repo and try it out. We support Docker Compose and Helm installation, so you can either deploy it on your Kubernetes cluster, or you can do Docker Compose up to run it. This is an online boutique sample application which we will be using for sending traces to Hypertrace. Like, this application consists of different start service, then recommendation service, payment service, and bunch of other services. Cool. So when we send the data from our online boutique app to like Jaeger endpoint, this is your Hypertrace dashboard, where you will see like various visualizations, like visualizations like calls per second and error rate and all that stuff. In application, you'll see how your dependency graph looks like your front end service depends on bunch of different services, and you can see those here. As well as, if you hover over any particular service, you will see all the details like latency, call rate for that particular service. It automatically identifies services and backends. So you can see, like, it identified Redis and SQL as a backend over here. Then, if you click on any of the service in the services panel, you will see a service dashboard, which is everything any service owner might ever need. Like, if you can see that here, you can see what endpoints a service is talking to, and details about each and every endpoint, your top endpoints, then your health radar, then again error metrics, call per second metrics, and latency metrics. If you click on the endpoints, so you will see bunch of different endpoints for your application. Click on any of the endpoint, and you will see endpoint dashboard, which is very similar to the trace dashboard we had with all that information. And these are all the traces from your particular endpoint. So if you click on any of those, you will see that you will see the spans for that particular trace. And if you go and click on see full trace in the top right corner, you will see the full trace for that particular endpoint. So here we are seeing that recommendation service is taking quite some time. and maybe like we will need to do some performance optimization there. So the problem isolation over here became easy because we can visualize latency very well, and we can see like what service is taking how much time, and we know it should take that time or not. So this is kind of cool application if you are looking for how you can use tracing. Then there are again separate metrics tab for detailed metrics for your endpoints. Then same thing for services again. So for from service dashboard, you go to traces and you can see traces for your service. There are various filters available. You can slice and dice on your traces. So if I set a duration greater than 300 milliseconds, I will get all the traces of duration greater than 300 milliseconds. If I click on any of the trace, I will see the detailed uh, trace view for that particular uh, call, and I can again the same thing. I can visualize latency. I can see what which service is taking how much time. I can see spans and trace for that particular call. Again, detail metrics for service, each and every service as well. So in the backends, we have we identify backend by default, so you can see detailed metrics for backends and traces as well. So in the Explorer, it is kind of like a SQL playground for you with visualization. There are a bunch of different filters. You can choose from any of the filter, and you can apply it like you can slice and dice using these filters on your traces. Uh, so if I want just protocol traces with the HTTP protocol, I can just click on a protocol. I can go set protocol to HTTP, and once I apply that, I will get all the traces with only HTTP protocol. So here you can add group by, you can add you can use bunch of different filters and pinpoint your requirement. So you can also change the duration. You can add any custom duration as well. So that's there. Cool. So that was kind of all about Hypertrace. Like that, this is how the generally tracing helps you, and this is how generally the tracing platform looks like. Uh, Hypertrace provides you this different features on top of Jaeger, Zipkin, and Hotel, like topology, dashboard, extensibility, interoperation operational way to perform the tracing, GraphQL APIs, and API and trace analytics. So if you are interested to check out Hypertrace, you can surely go and check it out on GitHub. And we have a Slack community. So if you want to contribute to Hypertrace, as it's open source, if you want to use it or try it out, you can join the Slack community for sure, and we will be happy to discuss around distributed tracing and Hypertrace with you. Then the Google Slides for this are available on this. Like you can just scan this QR code and get the slides as well. So thanks for joining in, and thanks the DevOps community for having me here. Like really grateful to be here with all these uh, great speakers and so many attendees. So if anyone has any question, or if you want to ping me, or like talk to me about something, you can mail me on jayesh.iv@traceable.ai, or ping me on Twitter at jayesh_iv. So thanks, guys.
Thank you very much, Jayesh. Now you can meet your audience in Zoom room to discuss all the questions, and thank you very much.